Hello, everybody. Welcome to Reinforce. Welcome to our session here on hybrid workload with IAM credentials featuring Discover Financial Services. My name is Jonathan Van Kim. I am a Senior Solutions Architect here at AWS. I've been working with Discover Financial Services for a few years right now, and later on I'll be introducing those two onto the stage, and they'll be talking about their story, their journey into AWS, specifically using IAM inside in the specific use case of hybrid workloads. So here's a quick agenda. So here we're gonna, eventually we'll get to the big story here, but first off, I wanna talk about IAM Refresher. So I'm gonna refresh everybody really quick and set the stage on what we're gonna be talking about. Another topic I'm going to bring up is security best practices in IAM. This is brand new, and I'm excited to talk about this and bring this, introduce you to this, and some of the best practices that are new. While they're new they're new to our documentation, but there have been practices in which Discover has been practicing for quite some time now. And we're going to go a little bit over IAM users and IAM roles and when to use those, and because of the new security best practices for IAM that just came out, we're going to talk a little bit about Trusted Advisor and IAM Access Analyzer. And the big portion of our presentation here is going to be Discover Financial Services. They have a wonderful story to talk about in terms of their use case with hybrid workloads, and I'm excited for you to hear about that, and hopefully you'll be able to relate to it and be able to take something back and be able to use that in your own environments as well. So really quick, IAM Refresher, recall the PARC model, P-A-R-C, the model. There's the principle, there's the action, there's the resource, and there's the condition. Specifically today, we're going to focus on the principle. So here, I decided to pick this policy. This is an S3 bucket policy that I picked out, and I picked it specifically because there is the principle that's highlighted in green because that's what we're going to focus on, but the action, which is S3, the resource, which is an S3 bucket, and the condition. It actually spells out PARC wonderfully in this order. And I'm to show you that the condition itself is optional. You can see the statement below does not have a condition. So it's an optional piece. So looking at the actual definition, this is actually coming straight out of the AWS documentation. A principal is a person or application that can make a request for an action or operation on an AWS resource with an optional condition, PARC. Now that we've gone through the quick IAM refresher, let's talk about the security best practices in IAM. This is brand new. It literally came out just about 2 weeks ago. I think it was around July 14th. And don't read all this. This is a wall text. I don't expect you to read this. However, I did put up a QR code. You're welcome to take a picture of this. I'll leave it up for a second. This QR code will take you to our documentation where we've refreshed our security best practices for IAM. We also will have a session later on today. The session number is IAM 201, and it's at 3:30 today with two of my colleagues who will go very deep into this topic. Right? And if you want to hear more about it, feel free to attend their session. So this next, I've decided to highlight a few of these, actually quite a few of these items in here. And what we're going to do is we're going to, like throughout this presentation and throughout Discover's story, we're actually going to subtly cover a lot of these security best practices. Again, these are brand new, and a lot of these Discover has actually been doing on their own and has been doing very well. So you'll see a lot of these elements throughout their story, and because of one of the biggest things that's new about the security best practices in IAM is that we actually call out IAM Access Analyzer in a few of these. So we'll be going over that service pretty quickly here soon. So when do you want to use AWS Identity Credentials? Our best practice is to use an IAM role. Use it whenever possible. Virtually anything that's inside AWS, there's no use case where an IAM user is actually really useful. Always use IAM roles whenever possible. Use them for applications or services on AWS, and now you also have the potential to use them anywhere. So just a few weeks ago, we also released a new service called IAM Roles Anywhere. So this allows you to use a role outside of AWS. And we'll go into a little bit of details about that at the very end. Nevertheless, we also, because of IAM roles, it also allows you to meet a few of the best practices. So require workloads that use temporary credentials. That is what an IAM role is capable of doing. If you're not able to use an IAM role, and which we'll go into our story here where there's lots of use cases where you can't, you also have to rotate those keys on a regular basis. So you'll end up with long-term credentials, and you have to find a way to rotate those. Let's go into a really simple example. So I'm trying to set this up for you to talk about the use case in which Discover is going to go into. This is a really simple use case in which why you would use programmatic access keys outside of AWS. In this case, we're going to be talking about IAM users with access keys and secret keys. In this diagram right here, really simplistically, we have a photo hosting website, web app hosted inside an on-premises data center. This application is connected to your iPhone, to your Android device, and it has an app that allows you to upload or download pictures. Now, this application may reside in an on-premises data center, but it uses AWS S3, Amazon S3, and Amazon Dynamo database. The S3 stores the photo, while the database stores the metadata of the photo. Now, in order for the application to function, let's say you uploaded a picture. Well, once the picture is uploaded to the application, it needs to store it. In this particular architecture, the application is going to store it in S3 and store the metadata in Dynamo. And to do so, it's going to use an IAM user with an access key and secret key. It's going to use programmatic access keys in order to access those APIs and perform those functions that this application needs to use. We're going to go into a little bit with services that help you with best practices. So I showed you that, and I think I saw a lot of folks take a picture of the QR code. But we are going to go into some services that help you meet some of those best practices. We have these services today. And the very first one is AWS Trusted Advisor. And specifically, we're looking at the security portion of AWS Trusted Advisor. Here's a quick console look at what AWS Trusted Advisor looks like. It gives you kind of like a cost optimization, performance, security, and fault tolerance. Inside that security pillar, we have identity checks. And some of these identity checks will line up with security best practices. And what I mean by that is that they'll help you look for those. It actually doesn't do any remediation for you. It just brings you, it generates a report and lets you find those resources that are non-compliant for some of those best practices. The very first one is IAM access key rotation. The next one is exposed access keys. If you have keys that might have been compromised, Trusted Advisor will let you know about it. IAM password policies to set the policy on that particular account. IAM use is to let you know how many IAM users you're using. And the very last one, which is another best practice we have, is MFA. Use MFA wherever possible. In this case, use MFA on root. We're going to double click on one more piece. Here is the actual access key, IAM access key rotation. As you can see right here, I have red resources and yellow resources. And what we're doing here is providing you an alert, a report of all the keys that might be older than 90 days. So yellow keys are getting close to 90 days, red keys are beyond 90 days. And it lets you drill down. You can go find these resources really easily. Just drill down and find them, and you should be able to remediate them or take action on them. These alerts, you can either find them directly inside the Trusted Advisor console. You can have these alerts shipped over to Security Hub if that's where your centralized security monitoring is at, or you can build your own dashboard and have it shipped to wherever you like it to be. The next service I want to talk about is IAM Access Analyzer. So one of those best practices is least privilege. So IAM Access Analyzer lets you, at least gives you some help to generate least privilege policies based on previous activity. So if you have a role or a user running for quite some time, it will analyze CloudTrail data and look at these are all the APIs you've been using and help generate a policy for you. And this is a good starting point for you to help refine the policies you have attached to it. It also helps you find public and cross-account access for resources using IAM Access Analyzer. This could be S3. This is a great tool for helping you to determine what your data perimeter looks like when it comes to resources. And then finally, IAM Access Analyzer. If you're unsure you wrote a policy that's good or bad or up to security standards, it does have the ability to validate your IAM policies and give you some feedback on how you wrote, how that policy is written. Now I'm going to start diving into a little bit more and kind of set the stage and tell you a little bit more about Discover Financial Services over the last several years. First, they started at the end of around 2016. And during that time, organizations did not exist. So we had a lot of handful accounts. These are very early on accounts. There's no management. Everybody's just trying to figure things out. So there's a lot of questions, and one of those questions is, what's the account strategy? Is it, we have, obviously back then, they didn't know organization existed, organization was not public. It did exist, but they were not allowed to, they did not know it was there. So they had to figure out a multi-account strategy. So how do you build a manageable multiple account strategy? As they progressed through the years, and there was increased demands. So for customers out there, and I've seen so many customers who come up to me and say, we started off in AWS, and we have all these groups that started to use AWS, and they're all over the place. They really like it. There's a high demand, and they're actually there's so much resources on AWS, we can't get ahead of it. So Discover experienced very high demand on AWS. And the reason why they experienced high demand is because the developers and application owners took advantage of the agility. So as I go further into this, one of the side effects of having high demand is that because all these applications are being deployed on AWS, they also wanted to have it deployed in AWS and have it a hybrid. It's like, well, maybe our database resides on premises, or we have our application on premises, and we want to use a specific service in AWS to make that application work better. So therefore, connectivity was brought up online, and now we have AWS Cloud and Discover's on premises connected, and now we have applications that are free to make, or that are able to make hybrid, be able to exist in a hybrid mode. Well, in a hybrid mode, now we have to go back to that original question: how do you do an application on premises call AWS API? At the time, when we were 2016, 2017, the only real solution was to use IAM users with access keys and secret keys. So therefore, this is what they have been using for quite some time. Compliance requires that you manage those long-term credentials. Now scaling, how do you scale past all this? Like how do you, all this growth and everything, like how, the infrastructure, the cloud team is not gonna grow as fast as the footprint's gonna grow. How do you scale? How do you manage all these keys without hiring a whole new, a bigger team to help manage that? In addition, since there's been a lot of applications being deployed, what's out there? What's the we haven't had visibility, so like what's out there? Let's discover what's out there. In discovering what's out there, we want to rotate those keys. So what are the unique requirements of those applications? The applications that are using access keys and secret keys, can they be automatically rotated? Can you write a script to do it? Or does it require human intervention to do it? So as I talk about this, the next one is unique customer requirements, human intervention. Like, what are the requirements from the human as involved in this process? Does the human want self-serve? Does the human say, hey, I'll write a script and I'll figure it out? Or I already have a process to rotate these keys. You need to write a solution to adapt to this process. So I'm extremely excited to be working with Discover for the last several years. Discover Financial Services has been a wonderful customer, and I'm really happy to introduce Nick on the stage.
Thanks, Jonathan. My name is Nick Bausch, and I'm part of a team we call Identity. And the Identity team is responsible for managing all IAM resources within our public cloud environments. So as our environment has grown, we noticed big increases in the number of IAM resources that we had in our environment. And there was a lot of cruft and things you would say was like, murky resources where you didn't really understand who owned the resources or what they were actually doing. And so we started looking at something we're calling IAM resource pruning. So we started off our journey with a small number of accounts split up by environment. So we had, dev, QA, prod, that sort of thing. And we started up with a limited number of users in the accounts, but cloud grew quickly, and more people wanted access to these accounts. And as a result, there was a lot of IAM resources that were created, and we couldn't figure out what policies were attached to what roles and if they were actually used. And then IAM users, we found keys that weren't expired, so we decided that we needed to approach this in a different way. And that's when we moved on to our multi-account model. We realized that we just couldn't manage the vast number of users in a small number of accounts. So we split up the environment into teams and products in the different accounts. And this provided us a benefit in that all of the different accounts were separated and all the IAM resources were separated, but also gave us some challenges with managing all of those resources. So we realized that we needed to have some sort of automation to allow us to keep up with the environment. So we created an internal management tool to create accounts as well as push changes to our accounts. We maintain IAM users for customers. We don't let them create them. We maintain global roles within our accounts and push them to all of our environments. And this is a busy diagram here. It's really not important, other than we glued a lot of different services together. And AWS has released Control Tower. We're evaluating it to see if it can actually do what we need to do to replace a system like this. So our challenges in the multi-account model. So we liked the fact that we were splitting everything up by team and product, but we also created a lot more users in our environment. We reached a peak of around 600 users at the end of 2019. And it's a lot of users, and we wanted to understand what we're doing. So, we had some third-party vendors that needed IAM users to be able to access things, but it's still just a lot of resources to manage. So a little bit about our environment. Currently, we're at 200 plus IAM users, over 10,000 policies, and over 12,000 roles. So we're not the largest environment, but we're also not the smallest. And trying to manage all these resources can be difficult. We're trying to drive down the number of IAM users, the number of static credentials that we have in the environment, and use only dynamic credentials. So we wanted to figure out, are these resources actually valid? And we wanted to dig deeper and figure out if they, what are they actually being used for? It just seems like a large number of resources. So what we found out is that no, a lot of these resources were not being used. There was IAM keys that had been used in a long period of time. There was policies that weren't actually attached to any sort of resources, and then roles that hadn't been utilized for some period of time. So we wanted to figure out why are these resources abandoned? So we went and we talked to our customers, and we sat down with them, and we pinpointed a few of our customers and said, what are these things? What are, you haven't used this in a while, what are these things? And the most common answer we got was we did a proof of concept and we forgot to clean up after ourselves. And I'm guilty of this too. I've done it many times where you implement something, you think it's going to be cleaned up real quick, and then you forget to go clean it up. And it's part of like the The cloud lets you innovate quickly. You throw something against the wall, you test it, you see if it actually works, and then move on with life. So now it was nice that we could sit down with the customers to ask them these sorts of questions, but that doesn't scale. We have lots of groups, lots of teams, and we can't actually get that sort of feedback from all the customers, and we couldn't actually take any sort of action on it. So why do we care? Why do we want to look at pruning IAM resources in the environment? There's several best practices that are published where we talk about trying to make sure that IAM resources are utilized, and then Discover's also under PCI requirements to make sure that IAM users are being used, that the keys are rotated on a frequent basis. Plus, it's just good hygiene in the environment to have the fewest amount of resources that you have and make sure that they make sense. So, challenges. We wanted to get customers to clean up resources, but just sitting down and talking with them and telling them, hey, go clean up stuff that's not used. That wasn't something they could understand. And they're busy focused on delivery of other products, delivery of new technologies, and they have their own individual goals that they need to meet. So we needed to design an automation that could take this action for us. So we collaborated with our cybersecurity team. If you look on the left-hand side, they have some third-party tools as well as some in-house applications they've developed themselves that look for resources in the environment that haven't been used. They then send us an SQS message with that information. We fire off a Lambda function, and we decide what needs to happen to remediate either a user, a policy, or a role. So if we just look at an example message here, it's pretty simple. We have two different types of events. We have a notification and a deletion. And just based off the ARN, we can understand what type of resource it is and what type of resource we need to take action on. So I like the simplicity of the model. It's not complex, and we can continue to add on to it. So resource remediation. We love infrastructure as code. Anytime we can leverage infrastructure as code, it makes it real simple to manage and maintain resources. However, we don't always have infrastructure as code. So if it is infrastructure as code, it's in a repository, check out the code, in this case Terraform, destroy it, and you're done. However, we do allow customers to create policies and roles in certain cases, and we need to be able to go clean up those resources as well. So in that case, we leverage Boto3 and Python to take those actions. So here's an example of policy cleanup that we have. We start with change control. At Discover, we love to monitor what's going on in the environment and make sure that everybody's aware of it. And then we move on to what's actually in the account that we're trying to clean up. So our application does an STS assume role into the account, looks at the policy, backs it up to a Dynamo database, and then looks for contact information for that resource. When our security team passes off a notification message to us, they provide an email or some sort of contact information for the customer, but it's more at the account level. We've implemented a tagging strategy on resources wherever possible that has a more specific contact that tied down to the team or tied down to the application. So we try to get more specific if possible, and then we default back to that CMDB value when we can't find it. And then we have a notification and a deletion, and the resource is gone. So challenges along the way. This wasn't always smooth sailing. We turned it on a limited number of accounts in lower level environments, and we accidentally deleted things that we had not intended. There were some automation users that were removed. There was some fire call or break glass roles in the environment that we accidentally removed. So we realized that even though some resources are infrequently used, they still need to be there. So how do you balance that sort of situation? So we came up with a few solutions. One is trying to standardize on naming of resources that should never be removed. And another one, because we had older resources in the environment, we just simply came up with exclusion lists. And finally, we made an SCP policy to ensure that we didn't shoot ourselves in the foot ever again. So what does a policy like that look like? It's very simple. We chose protected as the prefix for our resources that are going to be created within the accounts. And then only a special user, an administrative user, can delete those resources. So expanding use cases for this process, we have found other uses for it already that we hadn't actually intended. We had a third-party application that we retired, and we also had a third-party application that was able to change their environment from requiring individual IAM user keys to being able to STS assume roles into accounts. So this is fantastic. It reduces our footprint of IAM users that are in the environment. And since we already had the code there to remove IAM users, we could simply inject SQS messages and have all of these IAM users cleaned up from all the accounts. Another thing that we're looking at with our cybersecurity team is policy remediation where something is too permissive. So if someone creates a policy that has too many permissions, we want to kill it right away. We want to delete that policy, notify the customer and say, it's not allowed. We want to have that conversation immediately so that we catch it before it actually goes into production. We catch it before it becomes a problem, and we're not having that conversation later. So management of IAM users can be tricky, and rotation of IAM user keys is difficult. And my colleague Hiba is going to come up next and tell you more about a process that we've designed to solve that problem.
Hi, everyone. My name is Hiba Khaden. I am a principal infrastructure engineer at Discover. I've been managing the AWS platform at Discover for around 5 years. That's as long as I've been there too. I've been there through various roles. I've seen the cloud platform at Discover expand and grow from just a few accounts to more than 100 in just a few years. As Nick mentioned, all the measures we took in our environment were key in managing it. However, we still had a lot of IAM users to manage and stay in compliance with, as you can see from the graph. However, so many of you might be going through a similar cloud journey as we have been. We're still going through our cloud journey. We're still facing challenges. And I hope through the rest of this presentation for this session, you'll be able to take some things back and implement them in your own environments. Discover, as a financial services company, has to meet a multitude of compliance regulations. And as such, our strategy was to head to the cloud in order to support our data analytics and payments platform. But to do that, compliance with manual key management and without automation was super challenging. We needed to automate and standardize the management of these resources and create visibility of their use across the whole platform. Due to all of the risks that are associated with using IAM users, no one in our environment is really allowed to create them except for our AWS identity team. So that is restricted. We have set an approval process whereby, based off of the access being requested, use case, and business justification, IAM users will be created by our team to support their products, which means since they don't have access keys to create the users, we have to create the keys and pass it to them through a safe way. This is extremely, extremely tedious and super annoying too. So we automated the process and turned this into a self-service offering for our customers. Hold on. When I mean customers, I mean the teams that are using the AWS platform that we are managing, not the average cardholder, not you guys. Don't worry. We have our customers fill out a ServiceNow form. This form has multiple required parameters that help us enforce tagging standards, allows us to understand the business initiatives that require these integrations and their justifications for it. We also have them upload the requested access policy into the form so that our AWS identity team as well as the cloud security team can review it. Through this process, we review the access and it gives us the chance to give them feedback and have the whole thing documented. And once approval is done, we have reviewed it, approved it by both teams, ServiceNow triggers a Jenkins job, which creates the IAM users via Terraform. The Jenkins job then pushes the keys, so it doesn't just create IAM users, it creates IAM users, least privilege policy, the access keys. Did I mention access keys? Maybe I'm not following myself. All right. The Jenkins job pushes the keys to our secret store on-prem, and then it triggers an email notification to the requester with the path to the secret included in it, so that when the requester retrieves it, they can update their application at their own convenience. We don't need to create a change ticket and meet with them during a certain time, a certain day, none of that deal. All right, we created automation for IAM user creation, awesome. But now we have the challenge of maintaining all of the rotation of all of these keys for hundreds of IAM users. So what we did is we went back to the drawing board. We chalked out all the considerations that we believed the solution we would design would need to address. So for instance, how do we identify which keys need to be rotated and when? How do we notify customers that they need to take action? How do we enforce key rotation? Nobody wants to rotate their keys, so we have to force it, right? How do we notify customers that they need to take action, and since customers are not allowed to generate IAM keys in our environment, how would they then create new keys? After customer key rotation, how and when do we decide that old keys need to get deleted? Do we let the key simmer for a little bit? When do we make that judgment call that the key needs to be deleted, we're good to go? And most importantly, how do we remove humans from the process? Let me tell you, I was done chasing people to get their keys rotated. It's not fun. As a result, the solution we designed met every single one of these requirements, each one automated end to end, with certain flexibilities, of course, taken into consideration. There are just so many different scenarios that we can try to accommodate, right? So our solution addressed automated port generation, key creation, storage, secret retrieval, notifications, and key deletion. Let's dive a little deeper into the architectural design for this solution. We created a centralized Lambda, one that can be triggered daily by an event bridge rule. The Lambda starts off by obtaining a list of accounts from AWS organizations, account metadata from our DynamoDB table. This table contains information about contact details for account owners, the OU that that account lies in, and so on. The Lambda then assumes role into all of the accounts with minimal access, of course, to read the IAM user access keys and any details of that IAM user. After a certain period of time, after a certain, what am I saying? It also reads the tags for the IAM user too. So as part of our standardization of tags that I mentioned, for our IAM user creation request form, this is where it really comes into use. The tags for that are platform-wide standardized, right? And we use the data in there as well as data from the DynamoDB table to then generate a report and store that within S3. We then have the Lambda retrieve the report from S3, which then determines based off of the access key age, the access key status, whether the access key is active or not, if a new set of keys need to be generated. Once those keys are created, they are stored within our secret store on-prem, and the path in a specific path, specific just for that IAM user and specific for that account, right? We have multiple accounts. Many IAM users are named pretty similarly or the same, so there needs to be a distinction. All right, in addition to that, though, if there are existing credentials, IAM keys, in that path that the application still uses, what we do is we don't really delete that key. I mean, we only keep one at a time if there's an old key set there. So what happens is we rename that key. We try to make it easily identifiable, differentiate it from the new key that we're also putting in there. So at a time, we can store not more than 2 keys. And the way that's helpful, and the reason why that's helpful, is that when key rotation comes about and the application team actually ends up rotating their key, thank God, right? Sometimes it may not work. Sometimes all of their nodes don't get updated with the new key, and they need to go back, and they may not have time during that change ticket to figure out what's going on. So in that case, we have the old key there just so that they can just go ahead and use it until they can figure out what the issue was and resolve it. A notification via email is then sent out based off of the contact details that are present in the report. The email notification captures really the IAM user that's in question, the access key, the days that are left for the access key to expire. And when I mean expire, you guys know IAM user keys don't really expire, but till the deadline approaches, I should say. And the link to the secret path and any related docs and links to our self-service capabilities. Before I get into details of the additional self-service capabilities that we created, there are situations where, due to the type and the quantity of integrations that are taking place globally across our whole platform, we need to automate everything end to end. That only really works if the identity team really has the access to that application. And how we make that work is the event bridge rule that's used in the primary Lambda that I was talking about also triggers a secondary Lambda, which uses the tags and the IAM username to differentiate the particular IAM users that we can automate on the application end as well. So what the Lambda then does after identifying which IAM users it needs to rotate access keys for, instead of just leaving the secret, storing the secret in the secret store, it grabs the secret and rotates it within the application itself, does all its validations, and voila, we're done. Similarly, our customers have an opportunity to build similar automation on their end for applications that run in AWS and on-prem that they have access to, and due to application limitations, they can't use instance profiles. They can automatically rotate their keys by standing up a Lambda in their own account and retrieve the key from the secret storage and automatically rotating that within the application themselves. All right, now let's talk about the other self-service capabilities that we designed: self-service key retrieval and key disablement. We designed it to grant our customers the capability to rotate their keys at their own pace. Once the application team gets the email notification to rotate their keys, they go through a self-service request form in ServiceNow to get access to those keys. There is zero involvement of our team, thank God, in that process. Woo! Totally done with managing key rotation, right? And so they can automate the key rotation as well completely on their end, like I mentioned before in the previous slide. Once the keys are rotated, the app team then fills out the ServiceNow form a separate ServiceNow form to disable the keys. They don't have access to disable the keys, so we also have a request form for Jenkins to do that as soon as they fill that ServiceNow form out. All right, so once that key is disabled, we have that same Lambda that looks for the keys that need to be rotated. It also looks for the keys that are deactivated. So based off of the key status, it finds a list of all of the keys that are disabled, and during that same run, also deletes them as soon as it retrieves the report from the S3 bucket. And that concludes the architectural design for how we rotated IAM user key rotations. All right, I'm not done yet, guys. Relax. Root user access management. So IAM user key management is one thing, but then we also need to talk briefly about how we manage root user keys. And the short and sweet answer is, we don't. Yay! We never create access keys for root users, thank God. It would have been a complete nightmare. Trust me, I do not want to justify creating that to security. On day one of creation of an account, we slap on a password, slap on an MFA token, put that MFA token somewhere secure. I will never tell you where it is. And on top of that, security is absolutely obsessed with us never, ever, ever, ever using root users, right? So they actually have some monitoring on our logs, and they're explicitly looking for root user access. So anytime they see root user activity, you know they'll be trying to find you wherever you live, I swear. Anyways, when I say never use, I don't really mean never use. We still have use cases or reasons why we need to, use root users. So for instance, when we're requesting permissions for security assessments, whenever we're locked out of our S3 buckets, it happens. And whenever we're rotating our root password, which is not a fun thing to do. I wish I could automate that too. Maybe I will. Good idea. Now, let me talk to you briefly about a POC I'm hoping to work on. IAM Roles Anywhere was recently introduced just a few weeks ago, and we will hopefully be expanding the scope of our solution by working on IAM Roles Anywhere. IAM Roles Anywhere, if you guys haven't heard, is a PKI-based identity that allows applications or anything outside of AWS really to assume role. It really is there to, hopefully replace IAM users, which I'm sure security is going to be thrilled about. So it just requires us to work with our application teams, see how we can possibly integrate it into their apps, because that is a small complexity when it comes to IAM Roles Anywhere, but it's really cool stuff, right? No? Okay, tough crowd, God. All right, key takeaways. We're almost there, guys. Thank you so much for staying with me for so long. I hope you're able to learn a little bit from our cloud journey, the challenges that we've been through. We've made mistakes, we've learned from them, we try to fix them. There's obviously challenges with scaling, as many of you guys are going through, and challenges with, and the byproducts are not fun to deal with. But you know what? We're always continuously developing and improving our platform. So that's always a good thing to think about. There were challenges of managing IAM resources in our multi-account environment, challenges with abandoned IAM resources, and the manual compliance efforts that we had to impose, and lack of visibility to our end users as well. So we automatically enforced regulations and compliance. We automated remediation. We automated rotation. We did routine audits. We pushed back on IAM user creation, and we streamlined privileged resource management. Created self-service capabilities for IAM user creation, for key retrieval and disablement. And then we used naming conventions and SCPs to prevent oopsies, as you probably heard during Nick's talk. So yeah, well, thank you guys so much. Let me hand this over to Jonathan for the concluding remarks. Here you go.
Thank you, Hiba. Thank you very much for our story there. Thank you, Discover, for coming up here and presenting with me. I want to emphasize the story that came up here, in that they built a solution that was both not just, that challenged a lot, that solved a lot of technical challenges, were very obvious. There was a lot of application requirements. But the main point that I was very, very happy to hear and really loved about their story was that they were able to challenge a lot of the people aspects. People were involved in this process. How do we build a solution that was adaptable, that helped other people, all these internal customers who had different requirements, different processes, say, I need to do to rotate passwords in this fashion. They all had their own requirements, and they were able to build a scalable solution that helped manage these keys for both the technical aspect of the application, but also the people aspect for all their internal customers involved. Thank you very much for attending our session here. We're going to be, you go to the next slide. Please complete your session surveys. Those are inside the apps of your phone. We do take feedback, and we'd love to hear that. This is how we improve our presentations for going forward into future conferences. Also, if you have any questions or want to chat with us, we're going to walk off stage here, and we'll be happy to have a one-on-one or answer any questions you may have. Thank you so much, and thank you, Discover, for coming.